All right, guys, we're ready to start Chapter 4. In Chapter 4, we've mentioned already, it's all about functions. Okay, so your target for today, we're just going to focus on just starting to graph relationships as well as matching graphs with the situation. First lesson probably is going to be a review for you. If it's not, that's okay. If it is, just make sure you follow through and get all the points. So take a moment to copy down your learning target. I can graph a relationship and match graphs with a situation. While you're doing that, I'm just going to introduce Chapter 4 to you. So we did an activity already where we measured our forearm length and our height, and we're graphing the relationship. You guys are working on that already. We're going to be learning how to graph them, how to graph functions. We're also going to learn what is a function, be able to identify them as well as write rules for them. Okay, so if you've done some of this before, that's awesome. If you haven't, it's okay. We're going to be going through all of this as if it is new. So how are functions used? Right now I just want you to think of a function as a relationship or a graph. We will more formally define it tomorrow. The book gave you one example at the start of this chapter, how a graph can be used to illustrate many different situations, such as a cardiograph can help a doctor to see how the patient's heart is functioning. So you can often relate a graph to a given situation. In this case, the graph represents how the heart is functioning. There are lots of things that you can graph. We could graph the area of a circle, depending on its radius. Think about this. The bigger the radius, the bigger the circle, right? The bigger the area then is of the circle. If you have a really small radius, you're probably going to have a smaller area. So we could graph those points up here. You don't need to graph this, I'm just giving you some ideas. Also think about money. Okay, if the amount of money Joe makes depends on the number of hours he works, the more hours he works, the more money he's going to make. Doesn't always have to be a line. A lot of you are already thinking about lines, and that's great, but it doesn't have to be a line to be a function. Colin threw a ball in the air. The height of the ball depends on how many seconds it has been in the air. What's going to happen to that ball if you throw it in the air? You're going to throw it up in the air, and then after so many seconds, it's going to come back down from the air. So something like that. It may not be exactly that curve, but those can be functions. Last example I gave you, software engineers understand and use functions in their programming to make products to help you, such as Excel. So some of you probably know more examples. That's awesome. I just want you to copy down maybe 2 or 3 examples on your note sheet. It does not have to be one of these up here. All right, so the first thing we're going to do is we're going to relate the graph to a situation. I gave you a situation, and you're going to notice you're missing some words in your note guide. So if you need to pause the video, copy down what you're missing from this example 1. Okay, we're going to be given a situation, and I want to match the graph to it. Sometimes I think it's easiest to just draw your own graph and then see what's closest to it. But you can always do these 2 steps. So you want to definitely read the graph from left to right, to show time is passing. So all these graphs we're going to read from left to right, left to right, left to right. You also want to list any keywords in order and decide which graph shows them. So either list them in order, or you can highlight or circle them in the situation. So let's read this. The air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly again before dropping sharply. Choose the graph, we're going to say below here, that best represents the situation. So guys, you don't have to write this down, but I want you to think about this. What are some key words that describe what's happening? They either describe an increase, or they describe a decrease, or they describe that there's no change occurring. So take a moment, maybe pause the video, highlight what's important up here. If you're 1 second ahead of me, that's perfect. So we can see that the air temperature first is increasing steadily for several hours, and then it remains constant. So these are already kind of in order. They increase and then remain constant. At the end of the day, the temperature increased slightly again and then dropped sharply. So I want to choose which graph represents that. Take a moment, just read your highlighted words, and then read your graph from left to right. See which one of these graphs match. If I read this graph from left to right, I'm seeing that, okay, I remain the same, then I increase, then I decrease, then I remain the same. I have to start by remaining the same. Is that what I see here? No. can't be graph A. Graph B, if I was going to write my own situation, I would say that I remain the same, I increase sharply, remain the same, and then decrease sharply. Here I want to increase steadily at first. Again, can't be graph B. Let's check graph C. Do I increase steadily first? Yes, I do. That's checked off. Do I remain constant after that fact? Yes, look, the temperature does not change. It's flat there, so I do remain constant. At the end of the day, the temperature increased slightly again. Do I increase a little bit more on the temperature? Yes, I do, so I can check that off. And then do I drop sharply here in this graph? Absolutely, so it's graph C for this situation. Make sure you copy down step 2. You were missing this part right here. So if you didn't fill that in, you want to fill that in the box on your note guide. There's 2 different types of graphs, okay? You can have a continuous graph and you can have a discrete graph. They're pretty self-explanatory, especially if you look at what we have over here. Take a look at these 2 graphs. What's the difference between them? A continuous graph is going to be a graph that is a connected line or lines or curve. So it's connected lines or curves. It is continuous. It goes on continuously in between each point. Whereas a discrete graph is going to be made up of distinct points. I'm only talking about specific values here. Why would I need these 2 types of graphs, guys? Why would I need these 2 types of graphs? Think about that. Take a look at the examples here. This is going to be part of your extremely exciting ticket at the end. So I want you to be able to explain why you need these different types. Little comic for you to brighten you up in the middle here. Okay, so who's the wise guy? Take a look at my graph. We're going on the sales and it's shooting into the garbage can. Just a little humor. All right, next I want to be able to sketch graphs from situations. So Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. I need to sketch a graph for each situation and tell whether it's going to be continuous or discrete. Remember, continuous means that it's going to be connected, it's going to be continued on, whereas discrete is going to be distinct points. For these 2 examples, you do not need to copy down all these words. I just want you to draw the graphs on your note guide. When you're starting a graph, guys, think about what's realistic here. Simon's earnings. Can he earn part of $1? Can he earn negative amount of money? Can he sell negative amount of candles? Where's your graph going to be for A? Hopefully you're all saying quadrant A, or quadrant 1. So set it up in quadrant 1, label here, Simon's earnings. What are you going to put across the x-axis? So he's selling candles and then he's making money. The school's going to make $2.50. So which value is what's going into the function? Well, I'm making money based off of candles. So hopefully you put candles on the bottom and amount of money earned on the y-axis. Figure out what you want to scale this by. He has 10 candles to sell. So what's going to go across your x-axis here? Hopefully you're saying, all right, 0 to 10. How much money can he earn? For my y-axis, I need to know what I want to label on this side. How much money can he earn? Well, think about it. If he sold 0 candles, the school would get $0. How many candles does he have to sell? He has 10 candles to sell. How much money would his school make if he sold all of them? Hopefully you're telling me 25. So there's the start of your axes. I have my graph under there. I want you to pause the video, set up your graph, and then tell me whether it's continuous or discrete. All right, I'm going to get rid of this box here to cover up my graph. Hopefully you have a discrete graph here. He cannot sell part of a candle, and he cannot make all the amounts of money. He's going to make increments of money based off of the $2.50. So he can make $2.50, $5, $7.50, $10. There's no way he's going to make $11. Not exactly on the nose, right? Okay. Complete B. Pause the video and complete B. This is actually going to be your part of your ET as well. So you need to do that, and we will check it tomorrow in class. Last part then for 4-1, I want to also be able to write my own situation from a graph. So you have 2 steps you need to copy down. Notice on your paper you have steps written, but you need to fill them in. So step 1, you need to identify your labels. Step 2 then, you need to analyze your sections. So identify your labels. What are your X and Y axis labeled? Hey guys, you always want to remember to always label your axes, sorry. So you want to take a look, what am I talking about here? That's what your situation is going to have to be about. In this example, I'm talking about time and water level. Think about maybe giving yourself a little sketch before you come up with your whole situation. Well, notice here at the beginning of time, I have nothing. After some time, I'm going to have an increase. Then I'm going to have it be steadying out here. And then after some time, I'm going to have a decrease down. Your situation can be about whatever you want as long as it's school appropriate. So make it fun, make it something that you're interested in, and something that fits time and water level. You know what? It's October. I'm missing summer. I don't know about you guys. I used to have a pool, but I don't anymore. So if you have a pool, maybe you're thinking back to summer. I'm thinking maybe here at the beginning of summer, my swimming pool is filled. Using a hose. I'm going to say using a hose only because I slowly am putting in water. I'm putting it in at a steady rate. It's increasing steadily. Once the pool is full, it remains filled for the summer. And then you know what? At the end of the season, we drain the pool at a steady rate. All right? Never said it wasn't a baby pool, but there you go. So at the beginning of the summer, my swimming pool is filled using a hose. Once the pool is full, it remains filled for the summer, and at the end of the season, we drain the pool at a steady rate. Just an example, guys, of what you could do here. It doesn't have to be exactly that. For this first one, I hope you have a similar situation, but again, here's your other part for your ET. So you're going to finish this other example. On the calories, write me a situation that matches. Okay? This video is just about over, so again, to go over your ET, I want you to do B from sketching the graph for a situation. I want you to do the second graph here from writing situations for graphs. And I'm going to add on one more question at the end. Why do we need 2 different types of graphs? Why do we need continuous and discrete graphs? Explain that to me. So that's your ET, guys. Those 3 things, pretty simple. Tomorrow we're going to have a lot of fun with this lesson. We'll do some moving around in class and get you thinking a little bit more about these. All right, thank you.